from manufacturing and agriculture to healthcare and transportation, education, and residential uses. As demand increases, the need for sustainable energy sources grows as well. Solar energy has emerged as a promising source, but what if there was a way to make it exponentially more efficient? We'll explore in the U.S. National Science Foundation's Discovery Files. According to the U.S. Environmental Protection Agency, the amount of energy used by the average home has doubled since 1973. To meet this growing demand, emerging and innovative approaches are being explored. In an effort supported by the U.S. National Science Foundation and the U.S. Department of Energy, researchers at Lehigh University have developed a material that demonstrates the potential for drastically increasing the efficiency of solar panels. In a prototype using the material in a solar cell, they demonstrated an average solar power absorption of 80% and an external quantum efficiency, that's the amount of electricity produced by a solar cell compared to the number of photons that hit it, up to an unprecedented 190%, exceeding the theoretical efficiency limit for silicon-based materials. This efficiency leap is largely due to intermediate band states that enable the capture of photons lost by traditional solar cells. Although integrating the newly designed quantum material into current systems will need further research and development, the material holds the potential to greatly increase the efficiency of solar power systems and potentially play a crucial role in addressing energy needs around the globe. To hear more science and engineering news, including the researchers making it, subscribe to NSF's Discovery Files podcast.